Good afternoon, everybody. My name's Anthony Ligori, and I'm a senior principal engineer within EC2, and I am the engineering lead for AWS Outposts. And with me, I have Rich Rodolfo from Philips. He's going to come on stage a little bit later and talk a little bit about what they're doing with Outposts. But I'm really excited to be here today. This whole week's been amazing, but I'm really excited to talk about Outposts because the thing that I love the most, the thing that really gets me up every morning and it keeps me excited about my job is building a combination of hardware and system software to solve really unique customer problems. A lot of the times people think about the things like operating systems and hypervisors and hardware as just stuff that isn't really customer facing, but I actually think there's a lot of cool stuff that can be done and a lot of interesting problems to solve. And with Outposts, in addition to solving those problems for customers, you now can actually see and touch this hardware that we've been building over all of these years and do cool things with it. I hope everybody got a chance to go to the Expo floor in the Venetian. We actually have an Outpost Rack there. I think it closes during this talk. But it's been here all week, so you could actually touch it and take pictures with it and give it a hug if that's your kind of thing. It certainly is my kind of thing. So for this presentation, we're going to start out with what an Outpost is. We're going to talk about how it works. You'll hear a common phrase throughout this entire talk about sameness. But even though there's lots of sameness, there are new things with Outposts. One of the big new things is ordering and installation because unfortunately, it just can't be as simple as a single API request because we actually have to physically deliver something to you and get it installed. Then I'm going to talk a little bit about how we're thinking about services on Outpost, and I think this is one of the areas that's super exciting about Outpost because it brings so much of AWS to wherever you need it to be. And then finally, Rich is going to get on stage and talk about the things that they're doing with Outposts. And then towards the end, we'll do a Q&A section. Now, this isn't exactly the way that the marketing team wanted me to start the talk, but given that I'm an engineer and that I'm kind of crazy about hardware, we're going to start with pictures of racks, because this is what I care about, and this is what I really want to talk about. So this is an Outpost. It's about 4 feet long, 2 feet wide, and about 7 feet tall. So it's the standard size of a typical rack. What that means is that if you have an existing on-premise data center, it should fit into any of the positions that you have today, but everything on the inside is different from what you've probably seen before and what you've experienced, because over the last 7 or 8 years, we've been reinventing the way our systems work to really optimize to solve all of your particular problems. This is what the inside of the rack looks like. At the very top, we have a patch panel. This is where the networking comes into the rack and connects, and ultimately connects to your network. We've got servers in the center, switches. In the middle, there is a power shelf, which I'll talk a little bit more about. One of the questions I've gotten a lot this week is, what is all that black space? We build our data centers explicitly for EC2, and one of the things that we've done over the years is we've really optimized the density of servers. So we almost always have 1U servers, and they tend to have more horsepower than what you'll find otherwhere in the industry. A consequence of that is that our data centers have a lot of power, usually 2 or 3 times the amount of power that you'll typically have in a data center. So this is probably the most compute that you could fit in a typical data center, and it's power constrained, which is why it's half empty. But if you have high-end data centers with lots of power, we can fill it up a lot more than this. Like I said, we typically have 1U servers. This is what they look like. If you saw Peter DeSantis' keynote and he showed a server opened up with the 2 Nitro cards in it, that's these servers. So those exact same servers that Peter showed in the keynote, you can now get those servers in your data center. This is not a different hardware platform. This is not a different architecture. This is exactly the same stuff that we're using everywhere else within AWS. One of the big innovations that we've introduced in the last few years is something called a power shelf. So the typical thing that you see in a data center is every server has its own power supply. Power supplies convert AC power to DC power. And having a lot of little power supplies is far less energy efficient than having a centralized unit and doing all of the AC to DC conversion in a single place. Power consumption and energy efficiency is hugely important for us, so it's been something we've been investing in for a long time now, and we're able to now bring that to your data centers thanks to Outposts. Despite what some people have speculated on Twitter, those bottom drawers are not snack shelves. I would highly recommend not putting snacks in those shelves. They're extra space for additional power bays. Finally, this is the back, and you can see the large metal bus bar. This is what the servers actually plug into in the back, and this is ultimately what powers the servers. Okay, so we satisfied my need to show some pictures of hardware. I will be at least another 20 minutes before we see more hardware, but we'll get back to the normal presentation. So I showed a bunch of hardware, but what is Outposts and what problem is it really solving? Fundamentally, Outposts brings AWS, not just EC2, not just EBS, but AWS to your on-premise facility. The way we achieve this is by using the same hardware, the same software, and the same control plane that we use for capacity in our regions to your local data centers. It is fully managed. That means that we deploy the software updates, we perform all of the patching, and we perform all the monitoring, not just for software, but also for hardware failures. So if anything happens to the rack, we care for that rack just like we care for any other capacity in our data centers. And finally, as a user, you can interact with AWS Outposts just like you interact with any other AWS capacity. To launch an instance on an AWS Outpost, you use the same management console as the region that you ordered the Outpost in. It's not a different API endpoint. It's not a different SDK. It's not a different console. It's the same console, SDK, API endpoints. So I've said we've had this hardware for a long time. I've described how it all works. But this isn't a new problem that customers have, needing on-premise compute capacity. So why are we only introducing this now? There's a little story that we like to tell inside AWS that since AWS was first launched about 13 years ago, every single year in our roadmap planning, we had a plan for doing AWS on-premise. And every single year, we didn't actually get it done. It's been one of those projects that has gone on and on and on, and we've never actually been able to make it work. And so I wanted to talk a little bit about why this is such a fundamentally hard problem and why Outpost is so interesting in the way that it solves it. And to do that, we need to talk a little bit about how AWS works. So if I was going to launch an EC2 instance, and I was going to use the command line, and I was going to run an AWS EC2 run instances API command. At the surface, it seems like a relatively simple thing. I execute the command, and about 20 seconds later, I have an instance, and I can SSH into that instance, and everything works kind of the way that you would expect it to work. Well, what's happening underneath the hood is that when you execute that command, you're talking to a service. And just like a lot of you, the way we build our services is that we build microservices. We love microservices because we also believe in having small teams. You might have heard of 2 pizza box teams. And microservices allow us to divide our architecture up into things that small teams can operate and build and drive in an effective way. So the very first microservice that the AWS EC2 run instances call makes a call to is our API front-end service. And this is a service that handles authorization, authentication. It checks to make sure the APIs are well-formed. It does just enough work to figure out which other microservice it needs to hand the request to. The first observation is that we build our microservices to be AZ-aware and to have a multi-AZ failover strategy. So in order to stand up any microservice, we need hosts in at least 3 availability zones. Now, 1 host in an availability zone isn't good enough because 1, it doesn't allow you to survive spikes in traffic, but 2, if you have some kind of hardware failure, you'll lose that entire availability zone, and that's usually not a good thing or a good experience for customers. So as a rule, we always use at least 3 hosts in an availability zone. That means that every microservice that's part of the Run Instances API has to have at least 9 distinct hosts. They can't be on the same physical server, because if they're on the same physical server, you don't get the same failure characteristics that you actually need. The thing that happens after the front-end API microservice is usually a specific control plane front-end service. Front-end services are the things that typically handle business logic. They decide if you're going to create, let's say, an instance, I need to also create an ENI, and I need to create an EBS volume, and things of that nature. Again, this microservice requires at least 9 hosts throughout the region. And the other thing that I didn't previously mention, but is equally as important, is that every microservice has to be operated. I think the big difference between a service and a software product is that a service has an operations team behind it. It has dashboards that people are watching to make sure that changes in traffic aren't going to affect the service in a negative way. They have people to react for scaling and things of that nature. And importantly, they have alarms that if something is going wrong or unexpected, that a person will get paged and can do something about it. Every one of our microservices has a team of people behind it, monitoring and making sure that the system is healthy. After the front-end API service, we usually invoke some kind of database backend. It might be DynamoDB, it might be S3, it might be something custom. But as you can see, something as simple as a Run Instances API call ends up involving tens to hundreds or even thousands of these microservices. Now, this is all great because even though we're involving potentially thousands of these microservices and hosts, in something like an AWS region, it ends up being a drop in the bucket in terms of capacity. It's a very, very large system. You're getting economies of scale. And so we can afford to have all of these hosts and all of these microservices because of the scale of a region. Now, the problem that customers have always had is I need a rack of capacity in my data center. So the question is, how do you take something like AWS with the hundreds or thousands of microservices and actually put that onto a single rack? You have to make compromises. And all of the offerings that at least I'm aware of to date have made a lot of these compromises. The first one is your microservices can't have 9 instances. You don't have availability zones, so you're just not going to be able to have that architecture. What you usually do is just end up having 1 instance for a service. And if that one piece of hardware goes down, you're probably going to lose your API availability. So the net consequence of this is that you typically have poor availability in these types of offerings. The second one is this microservice architecture, which I think the entire industry really has been embracing because it enables you to be very, very dynamic and have a really high feature velocity. These get combined into a more traditional monolithic piece of software because you just can't afford to scale yourself out horizontally. You need to be really conscious about how much capacity you're using. This creates an uncanny valley because no matter how careful you are about maintaining API compatibility, when you rewrite a piece of software, you're going to introduce subtle differences if it's a different code base. The errors from APIs might be slightly different. The latency of individual requests might be different. It's just going to be different, and ultimately, you're going to have to port your software to that new, different system. I think POSIX is a great example of this. If anybody's ever had a program on, say, maybe I'm showing my age here, but HPUX and AIX versus Linux, even though it's highly, highly standardized by a large industry consortium, you can't write code that works on all of those platforms. You always have to have branching and conditionals, and it takes work to support new architectures. Finally, you're dealing with a fundamentally different software stack. It is not the same control plane that you're using in a public cloud architecture. This means you're going to end up with different features because ultimately, unless you're investing double effort in building for the public region and for the local environment, you're going to end up with feature gaps. And what almost always happens is that the one rack version of the software lags significantly behind in capabilities. Ultimately, one rack any kind of offering that says this is the cloud in a single rack, it's just not the cloud. I know that's a statement that a lot of people might get upset with, but I fundamentally believe that you just can't do that. It's just not possible. However, I'm here today talking about bringing the cloud in the form of a rack. So obviously, we found a solution to this problem. So let's think about how we could solve this problem. I like to generally look at these things and look at a simple, even if it's a ridiculous solution to a problem, and then try to figure out how to make that solution work. And so there is a kind of silly but accurate solution to this problem, and that is you take the customer's data center and you just connect the network to your data center, and you make the customer's data center an extension of your region. And then you can use your control plane to manage the capacity in the customer's data center, and everything will work. As long as you provide the same hardware and software, everything will just work. And you can have cloud in a customer's data center with a single rack. Because effectively what you're doing is you're just extending the region. That's all. You're just creating yet another data center that's part of the availability zone. But as I mentioned, this can't work. Fundamentally, one of the problems with this type of approach is that it violates trust boundaries. As part of the AWS shared responsibility model, we ensure the physical security of data centers. And if we tried to connect our network to another person's data center, we couldn't provide those same kind of guarantees anymore. The second problem is that you have a fundamental bootstrapping problem. There's this really interesting paper called Trusting Trust that talks about how you ever trust a piece of code that's compiled by a compiler, because ultimately something had to compile the compiler, and you end up in an infinite loop of trying to find the source code for the compiler that compiled the compiler, and at some point in time you just have to trust that you have a binary that is what you expect it to be. And so there's this whole notion of how do you establish an initial set of trust that something that may be malicious is what you expect it to be. And it's usually a really hard problem, and the way it gets solved most often, because it's easy, is you just say, I'm somehow going to get a secret on that device, and then I'll just rely on everybody having this shared secret. The problem is if you have physical access to a server, you cannot store a secret on it in a way that is 100% bulletproof that you won't be able to get to it if you have physical access. Ultimately, physical access is always, with enough effort, somebody's going to be able to get at the data there. Finally, and this one's a little bit more subtle, a lot of what happens in the public cloud really relies on having large idle pools. And particularly with software updates, a typical strategy for dealing with software updates is live migration. And live migration works great if you have lots of spare capacity where you can move things around and kind of reboot physical servers. But when you start talking about a single rack form factor, you just don't have the spare capacity, especially if it's a relatively small rack, in order to really make this work. So this approach, it doesn't work, but potentially these problems are solvable. And this is where Nitro comes in. So Nitro is an effort that we began in 2013. It was a long journey for us, culminating in 2017, about 2 years ago, when we launched the C5 instance type. Since then, every platform we've launched has been based on Nitro. And fundamentally, Nitro is three things. And Werner talked about Nitro this morning. I think Andy and Peter also talked a lot about Nitro, because it's been a fundamental shift for us in terms of what it enables us to do. And it all really began with us asking, if we were to build a system from the start, we were going to build all of the software and all of the hardware specifically for EC2 and to solve the problems that EC2 has, what would it look like and how would we do it? And what we came up with is three main areas. One is the Nitro card. The Nitro card consists of custom silicon that we build to enable I/O acceleration, a security chip which allows us to effectively address this trusting trust problem and really deal with servers without having to worry about how we bootstrap their identities. And then finally, the Nitro hypervisor, which, as Werner talked about this morning in his keynote, has the ability to perform what we call live update. So we're actually able to update all of the software on the platform while your instance is running without your instance having any downtime as a result of that. And so these three things really became a game changer for us, and they allowed us to look at these problems in a new light. And this is what we came up with. AWS Outpost is actually fairly simple in concept. Even though it allows us to do a lot of things that we could never do before, it really builds on all of the innovation that we've been developing over the last years. We take the same Nitro hardware and software that we're using in the rest of our data centers, and all we really need to do is introduce two new concepts. The first concept is the Outpost edge device. This is a device that sits in the rack, and it is the thing that establishes communication back to the region and effectively creates a VPN tunnel. The VPN tunnel is then used by these Outpost proxies to send control plane traffic down to the rack in a way that we've been able to establish is very secure, very robust, and doesn't actually bridge any networks together. It's just forwarding API traffic. You can kind of think of it like a very, very sophisticated load balancer. This Outpost edge device also acts as a network edge for the local rack. So your local network connects into the Outpost edge device, and it is the thing that acts as your gateway in your VPC, allowing the instances within the rack to talk to the rest of your network. From the AWS regions perspective, the Outpost proxies represent the servers that are in your data center. So for almost all of our control plane services, they talk to these Outpost proxies, and they don't even really care that they're servers in your data center. As far as most of our control plane is concerned, those servers are just part of our region, and they manage it just like our region, and all of the services see it and treat it just like it's any other capacity in the region. Because we're using the same AWS control plane, and because we're using the same hardware and the same software, you get the true AWS experience. The best way to explain this is, if you have a development team, and they write a piece of software, and they launch that software onto C5 4x large instances, and they do load testing, and they do stress testing, you gain a certain degree of confidence that I know when I run this software on a C5 4x large, it's going to meet my needs from a performance perspective. Now, that software probably runs on a different instance type. It may even run on a local server, but actually making sure that you know what the performance characteristics are and how things behave, it takes effort. You have to do work, you have to do validation. What we wanted to make sure is that if you had an application that ran in the public region, you could just take it, run it in an Outpost, and it would behave exactly the same way, because it's the same CPU, the same memory, the same networking, and ultimately the same underlying platform. Now, as I mentioned at the start of the talk, there are new concepts in Outposts that are necessary in order to be able to operate in your data center. The first one is a local gateway. So if you create an instance in an Outpost and it is in a VPC, it follows all of the same principles as any other instance in EC2. You have a route table, and there's routes in the route table. There's VPC local routes. And then you can add gateways. And you can add an internet gateway, a VPN gateway, or even a transit gateway. What we've introduced for Outposts that is new is the concept of a local gateway. And the local gateway is the thing that is connected to your network, such that even if your network is using private IP addresses like an RFC 1918, or even if you have public IP addresses, your VPC can talk to those addresses when the instances are in the local rack. The other new concept is when you launch an instance into an Outpost, the way you do this is by associating a subnet with the Outpost. So an Outpost has an ARN, just like any other AWS resource. And now when you create a subnet, you'll see that there's a new option for associating that subnet with an Outpost ARN. And then that is ultimately what enables you to launch services or launch instances or services into the Outpost. The great thing about using subnets as the placement construct is that almost all existing tools that accept subnets Whether they're first-party tools like CloudFormation or even third-party tools like Terraform will just work with this model. Ordering is the next new concept. The first step in ordering is creating a site. So one of the things we need to make sure of before you actually purchase an Outpost is that the location is going to be able to support the weight of an Outpost. The rack I showed you earlier in the presentation weighs about 2,000 pounds. You have to make sure that the carpeting can support it, things of that nature. There's a fair bit to just making sure you can physically roll the rack into place. The second issue is power requirements. We need to make sure that there's enough power, but we also want to make sure that you don't order a rack that isn't going to fit the power envelope that you have at a particular site. We validate the network configuration. An Outpost rack requires 2 uplinks. Those uplinks can be 1 gigabit, 10 gigabit, 40 gigabit, or 100 gigabit. And you can aggregate multiple uplinks into a lag, and we support up to 16 uplinks aggregated into a lag. So ultimately, you can bring a lot of bandwidth if you'd like to an Outpost. The next step in the ordering process is to actually select your Outpost configuration. While we can build an Outpost with any combination of EC2 instance types and EBS storage that you'd like, we've created a bunch of configurations that we think will satisfy a lot of needs, and we've pre-validated that they fit within common weight, power, and networking configurations to try to make the ordering process as simple as possible. When you're browsing the catalog, which everybody can do right now via the console, if there's a configuration that doesn't suit your needs, feel free to contact us, and we're happy to help define custom configurations for you. Finally, you submit an order. And as part of submitting the order, our installation team will contact you to actually schedule the installation appointment. We do the installation for you. You don't just get a box that shows up on your doorstep. We'll actually come in and do the install process as part of ordering the Outpost. On the installation day, an AWS technician will meet you at a loading dock. They will roll the rack into place, and then you provide an electrician to energize the rack. Once the rack is energized, we'll connect the uplinks, and then you can launch an instance shortly thereafter. If you're interested in what this process is like, we actually filmed an Outpost install here in Vegas a few weeks ago, and we've put a video on YouTube that actually walks through the install process and shows what it looks like to roll a rack into place. If you've never seen what data centers look like on the inside or what actually a rack install process looks like, it's a really cool thing to go and check out. Whereas installing a rack in a traditional data center and setting up software on it, I've heard customers say that it takes 6 to 8 weeks from actually having the rack arrive to when you can actually use it. A typical Outpost install will take 4 hours before you can actually use it. And a lot of that is waiting for electricians to arrive and things like that. Werner likes to say that all things fail, and he's absolutely right. We put a lot of effort into making sure our hardware is of high quality. We have lots and lots of data about how things fail. And at the end of the day, failures are just going to occur. It's part of having physical things. All of the active components in an Outpost rack are redundant. So there is no component in the rack that we expect can fail that will bring the entire rack down. And as a consequence, we can remotely monitor the rack. And when individual redundant components fail, our systems can try to identify, repair, and if we can't repair, we'll send you a notification saying that we need to come on site to replace a component. We will ship the component ahead of time to make sure that it's there in a timely fashion, and then we'll schedule a replacement with you based on when you're available to have us come into your data center. Typically, we're looking for a 2-day SLA to be able to replace a component so that we can meet all of our availability SLAs. And the installation and the servicing of an Outpost, including hardware replacement, is all based into the cost of an Outpost. It is not an additional thing that you have to pay for. You are paying for EC2 instances and EBS storage, and we are taking responsibility for making sure that you're always getting what you're paying for. One of the neat pieces of technology that's in an Outpost that now that you can actually see the Outpost, I can talk about is the Nitro security key. A common problem in data centers is what to do about data at rest. The typical thing to do, because you're not really sure whether the data's been encrypted and you're not really sure what's happened to the encryption keys, is a lot of data centers institute hard policies of destroying all non-volatile media anytime it leaves a data center. For SSDs and hard drive, that usually means physical destruction. If you've ever worked in a data center, you'll know that there are machines that can crush drives. Another common thing is for components that are not so standard, technicians will use drills and templates, and they'll literally drill holes in motherboards and things like that. Because we've built Nitro from the ground up, one of the things we did is we built the system with this in mind, and we know that all data at rest in a Nitro system is encrypted, and it not just is all the data encrypted, but all the keys are managed in a central tamper-resistant way. And the Nitro security key is actually an external device, and if you look carefully, you can see a little bullseye. And that bullseye is for a screwdriver. You can use a power drill or even just a hand screwdriver. And what happens is when you turn the screw enough, the screw is the black screw right there is actually sitting over a microcontroller that contains a tamper-resistant key. And that key is used to re-encrypt the key that's used to encrypt everything else on the platform. And you can be assured that when you physically destroy that chip, and screwing in the screw will physically shatter that chip, you've destroyed all the data in the server. And now instead of having to open up a server, remove a bunch of drives, and destroy all of these drives, you can destroy this little tiny microcontroller and be rest assured that all of the data has been destroyed. And this allows us to really easily come in, pull the server out, screw in the screw, put it in a box, done. Very, very simple process for doing hardware replacement. AWS is not, even though I'm a hypervisor guy, it's what I love the most, the virtualization bit is probably the least important part of AWS. The services are what's important. I wanted to talk a little bit about how we're optimizing services to work on Outpost. Now, we don't just want to lift and shift every service to run on top of an Outpost, because very quickly you'll run out of capacity. Because if we brought all those control plane services in, you'll have the same problem that we had at the start. So instead, what we're looking at is optimizing services to split apart the bits that are latency critical, that have to run on your premises, from the parts that are control plane services that can still run back in the public region. ECS is an example of a service where we really didn't have to do anything to make it work within an Outpost. The team did add a lot of features to make it work really well in an Outpost, but architecturally, it kind of just worked. ECS manages clusters of instances that you ultimately will run containers on top of. And each of those instances has an agent that reaches back and talks to the ECS control plane. And because of this architecture of reaching back and talking to the control plane, in the context of an Outpost, it just works, because you can talk back to the public region and everything just kind of makes sense. The Elastic Kubernetes Service, or EKS, is a service where we actually had to do a bit of work to change the way the service orchestrated itself, because every time you launch an EKS cluster, you actually create a new control plane instance. And so we had to explicitly teach EKS to launch the control plane in the public region and just rely on having worker nodes in the local Outpost. As you think about using an Outpost to solve your on-premises requirements and needs, I would highly encourage thinking about these types of architectures where you can split the control plane that runs in the region from the things that must run locally. If you think about it, even if you have a database that's super critical, has to be single-digit milliseconds from other things, you probably have batch workloads that run in the evening to do HR reports or something like that, where it would be really great to run that stuff in the public cloud using spot instances to reduce cost. You don't really want to use an Outpost for that type of work. And so having these types of architectures that can span local and remote can be a really, really great way of reducing your costs and improving your agility. On Tuesday, when Andy announced Outposts, we announced the following services that are available to run locally today. And these are all services that are optimized specifically for that split of control plane versus data plane. This includes EC2, VPC, EBS, ECS, EKS, EMR, and RDS is currently in preview. And he also announced a version of S3 that we're developing for Outposts that'll be available in the first half of 2020. And as you can imagine, S3 is particularly complicated to twist apart the data plane from the control plane, but we also know it's a service that customers are really excited about having in an Outpost, so we've been working on it since early last year. And finally, I just want to stress that even though these services are the ones that currently run locally, all AWS services are accessible in an Outpost. And there's a number of services like CloudFormation that we're most likely always going to keep in region because there's no real reason to have CloudFormation run locally. It's well-served running in the region, so that's an example of a service that we always want to keep in the public region. With that, I want to turn it over to Rich and let Rich talk a little bit about how they've been looking at and evaluating Outposts.
Thanks, Anthony. So I'm Rich Rodolfo. I'm from Philips, Royal Philips, as we're known. Some of you be familiar with us from the consumer space. We have consumer products that cross everything from general wellness to cooking to audio. We're everywhere. In the clinical space, we have a full range of healthcare products, some of which are in the critical care path. And so the things that Anthony was talking about as reasons to have this really come into play in some of the products that we have. We've been building solutions similar to the use cases Anthony's talking about for decades. And I will tell you at the outset of this, I've got a team that's been working on building small, remotely managed clouds in hospitals for about 20 years. And this is one of the hardest problems I've encountered in my career. Everything that he's talking about solving here, we've solved a couple of times and usually not as well as what we see here in Outpost, so we'll talk about that a little bit today. The product I'm responsible for from the operations and infrastructure side is the Philips Health Suite digital platform. This was started about 2013 to be our common cloud platform for all of the Philips products. It also is a platform that serves third parties. So we have pharma and other healthcare-related ventures outside of Philips running on top of it. As you can see, and this is probably a 3-day discussion, we're using just about every service that Amazon has or AWS has, and as soon as they release a new one, I've got people clamoring to figure out how to add that into our overall offering. Bringing services on-prem is an incredibly difficult problem for us, and so to Anthony's earlier bit around Uncanny Valley, it's exactly a problem we have. I can replicate all of my APIs on different hardware. I can try to implement them in a way it looks just like what I'm doing in the cloud, but it just doesn't work the same. And it doesn't work the same because the underlying infrastructure isn't exactly the same, and it's impossible to make that work right. So when we look at something like Outpost, it does allow me to pull this application that I have and run some of that functionality local. And why would I want to do that? I'd want to do that because I may have a large amount of data that is just too costly to move to the cloud where I'll then do some pre-processing. So you may want to do something, and it could be as simple as de-identification. You just want to anonymize it before it goes up there. It could be normalization. So many of the workloads in healthcare, though they adhere to standards, they don't actually implement the standard the same way. So you have a little bit of work you need to do before you can even begin to transport it. Some of it may not be designed to be transmitted away from the enterprise. Some of these technologies are decades old, so you may need to transform it or encrypt it or do something different before you move it off-prem. Second set of problems that we have is just regulatory regimes. There are certain things that we can't move off-site in some regions. And so, how do I tap into the seemingly unlimited scale of the cloud, but still satisfy all those local requirements? And that's where this comes into play. I can do latency-sensitive pre-processing on-site. I can do some data normalization before I move it. I can have site survivability in case the network is not reliable. And I've got systems deployed around the world, and I will tell you that internet availability is a problem. I've got systems that sit at the other end of satellites, so you may not be able to move the data fast enough or reliably enough to be able to process that. And if you're in an interventional situation where you're actually delivering care that is mission critical, that's probably not something where you want to rely on an intermittent connection. And I think the last thing that's important to understand is that some of the industry is just not ready yet. They're not comfortable yet with the idea of I'm going to rely solely on this thing that is far away. And this is a way for us to begin starting that, kind of risk-averse industry in this idea that we're going to move these services to the cloud. We can prove them first on-prem. We have a transitional path. There's a lot of things that are going on underneath the hood. We've been testing this for a few months. We had some very early versions of this, and I will tell you the kind of short summary on some of the calls that we've been having is it just works. Compared to other products where we've tried to kind of emulate a behavior in the cloud on-prem, for my folks, the learning curve was essentially flat. We were able to deploy our applications the same way we do in the cloud. The APIs that we use today to orchestrate everything just work. There's some small nuances, and I'm sure we'll get some of this in the questions later, small nuances of latency in terms of if you got to download an image to launch a new instance. That takes a little bit longer because distance comes into play. But from the application's perspective, we've seen no difference for the services that were listed in the initial release. I think we want to leave a little bit of time for questions, but so far this has been a great experience for us.
Great.
Anthony?
Awesome. Thanks, Rich. At this point in time, we'll take questions if anybody has any. If you could just come up to the front of the room, and then I'll repeat the question so the whole audience can hear it. Yeah, just right there is fine.
So can you set up auto-scaling groups where you have like some of these used in the rack and some in the cloud?
Yes, sorry, I was just thinking. It's always hard to remember to repeat the questions in situations like this. The question was, can you have an auto-scaling group that consists of instances in an outpost, but then also instances in the cloud? The short answer is yes, but I would not recommend it. So what I would instead recommend doing is having two auto-scaling groups and then using a metric to determine, and basically using the same metric on both. So like one of the patterns I really like is to say, I want to have an auto-scaling group that has a maximum number of hosts in it in the outpost. And then if you need more, then run the next auto-scaling group so that you can kind of conserve the capacity that's local and kind of just, when you scale into the cloud, not completely brown out the local outpost in terms of capacity availability. Yes?
Do you prefer power for the rapids? Is it 2 or 3-phase standard voltage?
Right. So the question was about the power for the rack. What is the preferred power? We support single-phase and 3-phase power today in common voltages that you see both in the US, Europe, and worldwide.
And what's the per cab power density that you see most often?
Right. The question was, what power density do you see? So we're currently offering Outpost configurations that are 5, 10, and 15 kVA. We can go higher, so if you want to do higher power density, we totally can do that. We often use 25 kVA in our data centers. It's just that we don't see a lot of folks that want that much power in a single position.
Thank you.
Yes.
I saw it on the slides that said RDS with retrieval. Do you know which database engines will be in there?
Yes. So the question was, the gentleman noticed that there's RDS in preview. The question was, what database engines? So MySQL and Postgres. Aurora is 3 AZs, and so we're still trying to figure out how to make Aurora work in the context of an outpost. But the common open non-Aurora database platforms are available in RDS.
And just one more. Do you know if EFS will be available?
The question was if EFS is available. So EFS is another example of a multi-AZ service that we're trying to figure out how to bring it into an outpost. One of the things we want to make sure that we do is in a lot of these services, and EFS is a great example of this, EFS has an amazing durability model. When you store something in EFS, it's not going anywhere. We want to be very sure that as we introduce these capabilities that we can figure out how to either replicate or at least appropriately message the type of durability changes. So EFS is something we're working on. The other managed file system services like FSX, I think you'll see probably sooner than EFS. Yep.
Maybe a couple of minutes quick. How does it scale beyond a single rack? Or does it scale beyond a single rack?
The question was how an Outpost scales beyond a single rack. So an Outpost today can be anywhere from 1 to 16 racks. We are working on designs of Outposts that will allow us to scale beyond that. We haven't announced a time frame for that yet, but you should expect to see that we come up with solutions that allow hundreds or even thousands of racks in an Outpost.
Does it have to be in the Outpost Rack? Like we've got a data center provider that has a very specific custom racks that they like to use for
Sure.
custom PDUs and like others.
Right. So the question was, does an Outpost rack have to come as a rack? Can we use it in existing racks, especially where we have custom PDUs? Unfortunately, the answer is no. So one of the things that that I feel really strongly about is I want to make sure that we don't deviate Outposts from what we do in our data centers. Our data centers, we deal with racks, and we always ship full racks, and we think of the system as a single combined unit. And so I don't see an obvious path how we'll get to individual servers, but we always listen to what customers are asking from us. And if that is a need that you have, reach out to us, let us know, and we'll always try to figure out ways of solving these problems.
That was a good answer there, by the way.
Thank you. It was a good answer, by the way.
The one final thing is what's survivable on an Outpost with loss of WAN connectivity? We have some squirrely locations that may go black for
Right.
3 or 4 days kind of thing.
Yeah, the question was, what's the survivability of an Outpost if the WAN connection fails? The specific example was sometimes we lose networking for 3 to 4 days. Losing networking for 3 to 4 days, that would make me nervous. I think you'd have to be very cautious about how you built your applications. So if an instance is running in an Outpost and you lose WAN connectivity, it's going to keep running. Now, in order for that instance to be useful, you probably need to use local DNS. You won't be able to use Route 53 back in the region. There are ways you can do authoritative DNS with Route 53 in the local region, so you can create configurations where you get the best of both worlds. This is another place where we're likely going to try to figure out solutions to help customers. Generally speaking, I feel more comfortable with kind of a few hours as a time frame versus a few days. Definitely, if you plan to disconnect for 2 weeks, that's beyond what I would think would be a good use for Outposts. I would say that's not the right solution for Outpost. Again, bring these kind of use cases to us. We're happy to talk to you about it. We're happy to work through them with you.
So, Anthony, just one thing that I would suggest on that topic, and this is something we've been looking at. Depending on how you develop your applications, you really want to rethink or revisit your architecture. To Anthony's point, if you're telling me you have a few minutes of downtime or network downtime or even a few hours, it's okay. I personally know how we've developed a lot of our applications in the cloud, and the developers, one of the problems with AWS is that they've made it very, very easy, and you don't encounter the problems that would have if suddenly a back-end service like CloudFormation that your app depends on is suddenly not available. So if you do a lot of dynamic scaling inside of your application, of course, that's going to be a problem on-prem. And so I think, again, the thing we have to be very careful of, the context is very close. It's a little bit different, so you always want to force that what is different with 1AZ, right. What is different when you lose the control plane. But it works, right. To this point, we've tested it. It does work straightforward for a long period of time.
Yep. Right. The comment was that they're often in weird locations where something political happens and you lose connectivity for 3 or 4 days, or potentially you're on a ship and the ship might be disconnected for weeks at a time. I guess one of the things I'll say about Rich is I love Rich and his team because one of the first things they did is they actually started testing disconnecting the Outpost to make sure their application would behave the way they thought. Anytime you're dealing with failure modes, the way to make sure that you're going to work with failure modes is testing. Constantly test that scenario. It's not an easy thing to do, so I would say that, especially for those multi-week outages, that's not the right fit. If you're willing to really put the effort into it and work with us, I think in the short term, we can probably figure out solutions for you. I hope that over the coming years, you'll find, and I expect that next year's reInvent, we'll have lots of awesome talks from customers like Rich and others. They're talking about how they're solving these problems with Outposts and that this will get easier over time as more and more patterns emerge. Next question. All right. The question was, with the local gateway, can you steer traffic from the region through the local outpost to the local network? The answer to that is right now, no. We've specifically disabled that. It's not really a technology limitation. We were concerned that would create weird things for customers that they didn't expect, mostly having routes that were duplicated and which path was taken. If that's an important feature for you, that's feedback that we would love to have. We're really trying to balance making it not kind of creating problems for customers with these types of things. So I would encourage you to give us feedback if that's not the right answer for you.
Yeah, and to add to that, so for my situation, and it might be for some of you, I'm bridging my software applications with a customer's network.
Yeah.
And so to your point, on boundaries of trust,
Exactly.
Suddenly you may inadvertently cause a penetration to what you think is a secure network if you're not very careful about it. And so I think, we'll probably have some similar asks about that, but we, at the moment, don't think that we know enough about how this is going to behave in the environment.
Okay. The question was about the pricing model. All of the pricing is available on the website today. Roughly speaking, it looks very much like a 3-year reserved instance. You can pay for it with all of the same mechanisms. You can do partial upfront, all upfront, roughly the same terms. So I would encourage you to look at the website to look at pricing. The question was, when do we expect Graviton support for Outposts? I love Graviton. It's I think one of the coolest things we announced this week, besides Outposts, obviously. We announced a preview for Graviton, so as Graviton becomes generally available, you should expect to see it in an Outpost shortly thereafter. All EC2 instances that we launch moving forward, you should expect to see in Outposts usually almost immediately.
Regarding trust boundaries, so if there's a need for a failover or just load balancing, the data can leave the Outpost or go to traditional cloud. Is that correct?
Right. The question was about trust boundaries and whether data could leave an Outpost and go into the public cloud. And the answer is yes, if you actually push it. So you have connectivity to, say, S3 from the local Outpost, and you can absolutely push data into the cloud, but you're in control of that. It's not something that we're going to just transparently do underneath the covers.
And then just one follow-up question is that we talked about, again, for redundancy, you want to have multiple racks. So if I'm a big company and I have many offices, could I just go and have multiple racks and sort of bypass any need for the cloud? Not bypass, but
Sure.
have that redundancy of my dozen or so offices so that there's never a need for me to go over to the traditional.
Right. So the question was, if I have a bunch of different offices, can I have Outposts in different offices and basically use that as a high availability strategy? You absolutely can create multiple Outposts and you can tie them to different availability zones. And when you do that, you'll inherit a lot of the same characteristics of an availability zone. But we can't guarantee that your multiple offices are actually going to be far enough apart that they'll survive natural disasters, have actually diverse power feeds from utility. That's a really complicated topic that takes a lot of effort to figure out. And then the other one is diversity of fiber. So one of the things we put a lot of effort into making sure is that different availability zones have different fiber connectivity, so it's unlikely that you would lose transit connectivity from all at the same time. So there's a lot of effort that goes into building an AWS region. It may be possible to get something that's a close approximation of that, but my suspicion is it's always going to be easier. In fact, we didn't really talk about it in the presentation, but I do want to emphasize, if you can run in the public cloud, it's going to be cheaper, it's going to be more robust, it's going to have higher availability, because not just do we design our hardware for EC2, our data centers are designed specifically for EC2. We have really advanced power, monitoring, cooling, and so you're almost always better off being in the cloud unless you have a really strong need to run stuff locally. The question was if we had looked at supporting Gov Cloud, and the answer is yes. I'm not sure if we put up a time frame on the website, but it'll come soon. Gov Cloud, like other things, have special accreditation requirements. It takes time to go through those accreditations. We're working on it, though. It will come.
Is it compatible with Direct?
The question was, is an Outpost compatible with Direct Connect? And yes, in fact, Direct Connect is highly, highly recommended. So for the connection going back to AWS, you have two options. You can do that via the public internet with a built-in VPN, or you can do a private VIF using Direct Connect. Direct Connect's definitely going to give you the best possible experience with an Outpost.
And then, given that means you can run consistent API calls without the need for your ISP, at least through that path, right?
That's correct. The observation was that you can use Direct Connect to have consistent experiences without involving your ISP, and that's absolutely correct. I actually think that the combination of Direct Connect and an Outpost gives you an experience where you have very high availability. You're not subject to congestion on the internet or kind of random failures from internet-facing traffic. And it also gets you jumbo frames, so you can drive much higher bandwidth. Lots of goodness comes from Direct Connect and Outposts.
Actually, follow up on that question, because when I selected a Colo partner to allocate some part of my services instead of my own data center, one of the key selection criteria was actually Direct Connect presence at these facilities. Are you planning to work with these Colo vendors as well to meet the racking and stacking and maintenance of these apps, or how should we see that in particular in Europe?
Right. The question was, do we plan on working with Colo Partners in order to rack and stack servers, do installations? Over the coming year, one of the things we're going to focus really heavily on is making the installation experience as clean and as simple as possible. We're very open for opportunities to work with third parties to make sure that we can meet customers wherever they need to be. Ultimately, whether it's Outpost or local zones or even wavelength, I think the common theme of all of it is we want to make sure that we have AWS everywhere our customers need it to be, and we're trying to figure out how to do that in the most effective way to meet as many demands as possible.
So in terms of local zones, how do I see the difference between Outposts and local zones? Because it seems to be a lot of similarity.
Right, so the question was, what's the difference between a local zone and an Outpost? Ultimately, it's all the same fundamental technology because it's all Nitro underneath the covers, right? So it's the same underlying fundamental technology. The difference between a local zone and an Outpost is that you can choose where an Outpost sits relative to the rest of your network. That means that if you want to have sub-millisecond latency, you can actually control the fiber distance to whatever system you care about. You can eject it deep within your network. With a local zone, you're always going to be transiting some kind of backbone fiber or something like that. So ultimately, it comes down to latency and whether and how much control you want over the physical hardware itself. Okay, the question was, are the services the same? It's different just because of the nature of the way local zones work. I'm not actually sure what we announced in terms of services with local zones, so I would suggest checking the website. I just didn't catch that part of the keynote, so I don't have the answer offhand. Yeah.
Any thoughts on minimum bandwidth and maximum latency tolerance between
Right.
Outpost and
The question was minimum bandwidth and maximum latency tolerance, and we just have a few more seconds. So the latency, we've tested up to 150 milliseconds. I think that's where we're at right now. This is something that we're going to push the envelope on down the road. Bandwidth, we recommend a gigabit of bandwidth, although the rack really only needs 10 megabit, but we think the best experience is going to come with a gigabit. Just one more question before we have to stop.
How would you like AWS multi-account strategy?
Okay, the question was, how does it look with multi-account? The answer is you can absolutely use multiple accounts. In fact, you can share an Outpost with any account within an organization. So if you use AWS organizations and have many accounts, that'll work just fine with Outposts. So I'm out of time. We're out of time. Thanks, everybody. Really appreciate it.